Hello everyone, today we're going to talk about simple truth and method of join. Today's objective is first define what is a simple truth. Then we need to determine what is the zero force member and how to analyze all the internal force in a truss. So our outline today is first we talk about application of truss, then what's the definition of simple trusses, and there is two methods to analyze a truss: method of joint, method of section. Method of joint is easier to analyze, method of section is less time consuming. But today's topic is about method of joint. Then we are going to introduce zero force member, and as always we solve some example to apply what we learned. Let's see what's the application of simple truss. Simple truss, you might see it's usually used commonly used to support roofs. And as an engineer, we need to select their size. What is the minimum size we can find to satisfy all the loads? We have two types of trusses. One is two-dimensional. One is two-dimensional. So this is two-dimensional truss, and the other one is three-dimensional or space frame. You might see some of application for trusses, for bridges, or for when you go shopping malls. Whenever we have a large span, we use simple truss. And if you look at the pattern in all these trusses, you can see all these triangles, right? Triangles here, so there are combination of a lot of trusses. So why we use trusses? First of all, whenever we have a large span like sport stadium, the way that we can satisfy the load, for example, if I have a load here, we need to have a column, right, to transfer this force. Who wants a column in the middle of the field or somewhere that block the audience eyes, or people who sitting in the sport stadium? We don't want this, right? So the way that we use trusses, we usually transfer loaded to the column that are outside. Why we use truss? First of all, as you can see, they are a slender member. They are so tiny. That's why the material, we use less material, so it's a cost-effective solution. The other advantage of using truss is easy to inspect and easy to manufacture. So it's very easy to make it, easy to manufacture, and easy to inspect. All right, what is the third advantage? The third advantage is it's really satisfy the load in a large span, and it's very safe. All right. Let's see other application for trusses: crane or aircraft or a space station. So it's a perfect structure to carry a lot of different loads. So here is a simple truss. So if you join two a slender member like this one and this one, make a triangle, and at the end you use pin, you made a simple truss. How it carried the load? We have a purlin here, so the load goes to here and here, then we can apply all this load to the joint. All right, so and we already learned how to find the support reaction. So here is a support and here is a load transfer load from purlin that is applied on the joint. Like previous lecture, we know we have some structure that are stable, some structure are unstable. If the number of member is 2 times of joints minus 3, the structure is stable. How about M is greater than 2j minus 3? In this case, the structure is not stable, it's indeterminate, that you will learn about it in future courses. But for now, we just focus on the structure that they are stable and determinate. All right, how about if the number of member is smaller than 2j minus 3? If the number of members is smaller than 2j minus 3, the truss is not stable. It's not something we want to analyze. All right, let's see some assumption about trusses. First of all, we excuse me, we expect all the weight for truss is negligible compared to the load, external load, and reactions. Second, the members are joined together by a smooth pin. Sometimes we use bolt or welding, but our assumption is they are just smooth pins. The third assumption is all members are either in tension or they are in compression. So we use T stands for tension, C stands for compression. All right, let's solve an example and see why we call this method of joint. So we use method of joint to analyze this structure. So the reason that we call it the method of joint is we take off one of these joints, draw free body diagram, we consider external force. Here is only 500. We might some have other external force like AY, AX, CY, that we call this support reaction also external force. Inside the members, we have some other load that we call it internal load. So we call this load internal load. So if you look at joint B, we have two unknown and from equilibrium equation, we have two equations, right? What is those equations? Sum of fx equals 0 and sum of fy equals 0. So the maximum unknowns per joint should be 1 or 2 to be able to find it with equation of equilibrium. Now let's see what is the step-by-step problem solving strategy to analyze the truss. First of all, we need to draw free body diagram of entire truss, not just a part, entire truss. Then we need to determine the support reaction. What is the next step? The next step is free body diagram of the joint. So this is a free body diagram of joint. The first one was free body diagram of the truss. Then what's the next step? The next step is apply equilibrium equation. Sum of fx, sum of fy equals 0. We can assume all the members are in tension. If we get negative, we know the direction we assumed is wrong. If you can guess what member is in tension, what member is in compression, it's okay. But if you cannot, you just can um, you just can um, see what you get in final answer. All right. Then after we finish with one joint, we move on to the next joint and repeat the same procedure to be done with all the internal forces. All right. Before we analyze all the for all the internal forces in a truss, it's good to know what is the zero force member, because those members don't have any force. Look at this truss at joint A and joint B. If you have two members that they are non-collinear, like AE and AB, and there is no external force or support, these two members are zero force member. In this case is A and E. Now look at joint D. Again, it's the same scenario. There is two non-collinear member without any external force or support. So they are zero force member, right? So there are zero. So this is the case number one, that when we have two non-collinear member. The good things about zero force member is we can remove zero force member and the structure is still working. All right, let's see the second scenario that we have zero force member. In case 2 is when we have collinear member ED and DC, then there is a third member that is non-collinear member. In this case, this member is 0, the non-collinear one. So anytime it's a 3 members, 2 of them are collinear, but there is no external load or reaction, the third non-collinear member is a zero force member. Look at joint C. You can see the same thing. DC and CB are collinear and AC is the third member that is non-collinear. So this one is 0. All right, let's see what happens if we delete these two members. Nothing happened. Again, the structure is stable and can satisfy the load. So why are we using a zero force member? Because first of all, it increases stability and rigidity of the truss. Second, if we have various loading condition, it can satisfy different loading condition. Let's solve an example. So in this example, just we want to first find the zero force member. Which member is zero force member? If you look at these AB and AC, they are collinear. The third member is non-collinear and there is no load or external support. That's why this member is 0. So I already know this member is 0, the internal force in this member. Now it's time to analyze this truss. For this one, I start with joint D and see how I can analyze joint D. Okay, let's look at the free body diagram of D. We have one external load for 150 pounds and there is two internal load that we don't know how much is it. Okay, so we want to find DC and AB, the force between in these members. Okay, so this member DB was 0, that's why I removed it. So it's 4 feet by 4 feet truss, so the angle is 45. Now I can draw coordinate system x and y. Then apply the equilibrium equation and find unknown. So I have two unknown and two equation. Sum of fx equals 0 and sum of fy equals 0. Okay, stop the video and try to find the forces that are unknown. All right. If you write sum of fx, sum of fy, you can see in the x direction it's only 450. It's 450, and also the x component of FCD and x component of FAD, which is FAD cosine 45, FCD cosine 45. For sum of Fy, we only have two y component of FAD and FCD. If we solve this system of equation, we can find FCD and FAD. So we found this force member and the force in this member. This one also was 0. All right. If you look at the answer for FAD, you can see we got negative. Our assumption about FAD was in tension. We got negative, it means our assumption was wrong, and this member is in compression. All right, let's move on and see the joint A. At joint A, if we take out the joint A and draw a free body diagram, we know from previous joint FAD is negative 318. So we know this one, we don't know this one, we don't know this one. Again, we have two unknown and two equations. So it's easy to find these two unknowns. All right. The only things that we need to do is write sum of fx equals 0, and then we can find the internal force in FAB. If we want to find AY, we can use sum of Fy equals 0 and then find AY. But in this problem, we only want to find internal force. At this time, we have all these internal force, okay? Do I need to analyze joint B or C to find BC? No, I don't need to. Why? Because if I take joint B and this one is 0, it's only FAB, and this one is FBC. If I write sum of Fx equals 0, the result is FAB and FBC. So I analyze all the truss. Let's have a concept quiz about zero force member, if you still remember. At this truss, we want to know how many zero force member we need. Stop the video and think about it, and then come back and see if you got the right answer. Now, look at this member. They are two non-collinear member without any external load. So they are zero force member. Look at this one. Two collinear member with the third non-collinear member. So from here, you know, this member, and not this one. The third one is zero force member. So this is all zero force members. So how many zero force member we have? 3. Or let's solve another example and see how these methods work. So first of all, in this truss, you can see two external force. So they are external. And we want to find all the internal load. First, check if there is zero force member, then draw free body diagram for joint D, C, and E. And then apply equilibrium equation. So look at joint D first. Can I analyze joint D even without finding the reaction? Yes, because there is two unknown. These two force member, I don't know. And then I have two equations to find these two unknown. So let's start with joint D. So I draw free body diagram for joint D, and if you can assume FCD, you know FCD is in compression and FTE is in tension, it's okay. If you cannot, you can assume everything is in tension, and then at the end you might get negative for FDE. Okay, let's stop the video and then write the equilibrium equation, find two unknown forces. So if you write sum of fx equals 0, the only fx component is this one. Let me change the color. So in the x direction is this one, and also x component of this FDE 3/5. All right, so this is all you have for x component. Then similarly, you can write sum of Fy. So if I write sum of Fx, I can find FCD. Now it's time to find sum of Fy, and from here we can find the next one. Similarly, we can, after we're done with joint D, we can start analyzing joint C. We have one external load, 900 Newton, and 3 internal load. But we already know what is the force in FCD from analyzing joint D. So this is a recall from joint D analysis. All right, now you have two unknown, and it's easy to write equilibrium equation. Now stop the video and find these two internal force. From writing sum of fx, you can see the only x component is 900 and FCD. So FCD is 900. For Fy, the only forces in this direction is 800 and FBC. Now you can write sum of Fy, and they are equals, they are 800. Now let's move on to the next joint. What's the next joint? Is joint D. From joint D, we found out this member. From joint C, we found this one. So the only member that we don't know is this one and this one, okay? So this is a free body diagram. Stop the video and write sum of fx, sum of fy to find these two components. So here is the equation. I write sum of fx, sum of fy, and from solving the system of two equations, I can find this internal number. Let's call it a day and make sure you do the assignment that is posted on Canvas. Have a good one.